Salam and welcome everyone. So today we're going to be working on the question on the screen that says calculate the pressure exerted by 1.0 mole of ethane behaving as a van der Waals gas when it is confined under the following condition. The condition is at 273.15 Kelvin in 22.414 dm cube. So the first thing you have to note is that we've been given a bunch of parameters and we've been told that we're dealing with a van der Waals gas. So for a van der Waals gas, we were asked to find the pressure. Now, the first thing you do is for you to write out all the parameters you were given. You were given the number of moles, which is 1.0 mole. Okay. We were given the temperature to be 273.15 Kelvin. You were given the volume to simply be 22.414 dm cubed. Of course, the identity of the gas is 2C2H6, so it's ethane. Now, the next thing you're going to do is for you to write out the van der Waals equation. The van der Waals equation to determine pressure is P equals RT, R being the gas constant, T being temperature, divided by the molar volume Vm minus B, okay, minus A divided by Vm squared. Now, I want to quickly mention this. I know I just said B. B is a van der Waals parameter and A is also a van der Waals parameter. The V van der Waals parameter involves extruded volume while A involves attractive forces. So as you can see from the information we have, we know the gas constant because it's constant. We know the value for temperature because we're given the question. We know the value of volume, but not the value of molar volume. But because we're given the number of moles, we can always determine the molar volume, which is just simply molar volume, okay? It's just simply volume divided by number of moles. And we're given the volume to be 22.414, okay? dm cubed divided by the number of moles, which is just simply 1.0 mole. So what you end up with is just 22.414 dm cube per mole. So that is basically the answer. So that is it. So now we have the value for Vm now, and of course Vm squared. Now what is left for us is for us to say what is A, because we need A and we also need the value for B to determine the value for P, because when we have the value of A and B, that's when we can substitute with other values to determine pressure. So it's important for you to know that for van der Waals gas, the values of A and B is unique for each gas. So that means that for me to know what the van der Waals parameters A and B is, I have to look for what is what it is for ethane. So like for example, we're given H2 gas or O2 gas is going to be different from gas to gas. So looking at the Atkins Physical Chemistry 11th edition textbook, I would look at the resource section, which is at the back of the textbook, and I determined that the value for A is simply 5.507 atmosphere, okay? dm6 per mole squared, okay? And then value for B is simply 6.51 times 10 to the power of negative 2 dm cubed per mole. So that is it. Note that this textbook, in case you have a physical chemistry Atkins 11th edition textbook, has the resource section at the back of the textbook, and all the information you need to solve all the questions in the chapters of physical chemistry is there, just like this parameters A and B is also there. So now we have all this information, we can just simply substitute. But before I go on to substitute, let me rewrite the equation and then we can continue from there. So P is equal to RT, molar volume minus B, minus A divided by molar volume squared. So P equals R is 0.08206 dm cube atmosphere divided by mole Kelvin times the temperature. So what is the temperature? We have the temperature to be 273.15 Kelvin. So that will be 273.15 Kelvin, okay, divided by the molar volume, which is 22.414 dm cube per mole. So 22.414 dm cubed per mole, okay, minus B, which is just 6.51 times 10 to the power of negative 2 dm cubed per mole. Our work, of course, is not done because we have this information here that we haven't substituted. So I'm going to say a minus here, a big minus. And then, of course, the value for A, we know that to be 5.507. So 5.507 atmosphere dm raised to the power of 6, okay, per mole square, or I'll just say mole raised to the power of negative 2, divided by Vm square, which is the molar volume square. Molar volume is 22.414 dm cube per mole. So that will be 22.414 dm cubed per mole all squared. So this is basically what we have. Yeah, that's how we do it. So let me start canceling whatever I can cancel. I can cancel out the Kelvin here. So we can, go on to math since we have successfully substituted everything. So I'm going to say pressure equals the numerator 0.08206 times 273.15 would give us 22.41469, okay? dm cubed atmosphere per mole, okay? Divided by 22.414. So this one at the bottom is what I'm trying to do. dm cubed minus 6.51 times 10 to the power of negative 2, which is just simply 22.3489 dm cube per mole. So we've subtracted the information at the bottom. So this minus the other part of the information, 5.507 atmosphere dm6 per mole squared, okay, divided by 22.414 dm cube per mole all squared. That's going to give you 502.3874, okay, dm6 per mole squared. So that is it. Yeah, so you have the information so far. Of course, now we can cancel out more units. So cancel out dm cube mole mole, and of course dm6 mole squared. So you end up with 22.41469 divided by 22.3489 atmospheres. When you do that division, you end up getting 1.002944 atmospheres, okay, minus 5.507 divided by 502.3874 atmospheres. Of course, when you do that division and you put on your calculator, you end up getting 0.010962 atmospheres. So the pressure would end up being 0.991982 atmospheres. So, of course, because of this is a chemistry question and we're chemists solving a question, you know that you're not going to leave this in this amount of raw values. You have to pick the lowest number of significant figures for the values that we're giving the question, and that determines the number of significant figures for your final answer. So, what this is that we're going to go back to the parameters we used to solve the question and see the lowest number of sig figs that we used. So we see that we're given number of moles, 2 sig figs. Here we have 5 sig figs for volume, 5 sig figs for temperature, 4 sig figs for A, 3 sig figs for B. Well, the one with the lowest number of significant figures is the number of moles, so that's 2 sig figs. So we have to put our answer in 2 sig figs. So the value for pressure would be 0.99 atmospheres. And this is how you answer this question. So I have done another question very similar to this, where the values are different, but the concept is the same. So make sure you watch that video. The question is gonna be on the screen right now. Yeah, if you have any questions, please put in the comment section. If you have any concerns or suggestions, also put in the comment section. I'm an online tutor who helps students who are struggling or who are trying to improve and succeed in all their STEM related subjects, whether they're in middle school, high school, or college. I also help mentor students who are trying to navigate your academic life. So if you need any of my services, make sure you email me at shahabitutoring@gmail.com. I wish you guys all the very best. Assalamu alaikum wa rahmatullahi wa barakatuh.